Hey viewers, welcome to my channel Keep Calm and Love Maths. So in this session I will explain the remaining part of the function from the previous classes. So in the last class of function I have already discussed about the types up to the type number 3. Now the type 4, which is into function. Type 4, a function f from a to b is said to be into if there exists at least one element of b which is not an image of any element of a. A function f from a to b is said to be into if there exists at least one element of b which is not an image of any element of a. So I will like to explain the definition of into function with a figure. So here it is. Let us take two sets A and B. A contains the elements 1, 2 and 3 and B contains A, B and C. Now 1 is related to A, 2 is related to B. And in the set B, we can see here the element C is unrelated. So the definition says there exists at least one element of B, which is not an image of any element of A. So here in this figure, C is not an image of any element of the set A. So this function can be called into function. This is the definition. I am giving another example too. Let us take a function f from R to R, that means set of real numbers to set of real numbers, and it is defined as f of x equal to modulus of x for all x belongs to the set of real numbers. This function is also an example of into function. You can make a figure like this. This is very obvious. This is an into function. Now type number 5. Number 5, a function which is both 1, 1 and onto. A function which is both 1, 1 and onto is called bijective function or bijective map. So this is the definition. Let us take an example. F from R to R such that f of x equal to x for all x belongs to the set of real numbers. So this is an example of bijective function, because if we draw a figure like this, we can see this function f will be 1, 1 as well as onto. So this is a homework. You can go through the function f which is bijective. You can check it. Come to the exercise part. Now come to the exercise part, and this is an exercise from the book A Class Book of Mathematics by XII. The first question is the function f from a to b 1, 1 and onto? So here we are given some functions which we need to check whether these functions are 1, 1 and onto. Number 1, so there are given two sets A and B, A equal to 1, 2, 3, 4 and B equal to A, B, C, D, and the function is in a way 1a, 2b, 3c, 4d. So we need to check whether this function is 1, 1 or onto. For that, this is very easy process. There is a very easy process. So if we draw a figure of this function, then we can easily tell whether this is 1, 1 or onto. So let's say here the figure is in the set A. There are 4 elements 1, 2, 3 and 4, and in set B, A, B, C, D. So 1 is related to A, 2 is related to B, 3 is related to C, and 4 is related to D. Now, according to definition of 1, 1 function, each and every element of the first set should have distinct images in the second set. So here it follows 1 has the image A, similarly 2 has image B, 3 has image C, and 4 has image D. Therefore, this function is obviously 1, 1. Now, for onto, now to check onto, according to definition of onto, for any elements of the second set, that is B, there should be some pre-images in the first set. So we can see here A has pre-images 1, B has pre-images 2. Similarly, C and D also have pre-images in the set A. Therefore, this function is onto also. Therefore, this is a function which is 1, 1 and onto. Now question number 2 is set A where the elements are 1, 2 and 3. The set B contains elements A, B, C, D. And the function is defined as f equal to 1a, 2b, 3c. So we need to check whether this function is 1, 1 or onto. It may be 1, 1, it may be onto, or it may not be 1, 1 or may not be onto. Let's see. So the figure shows 1 goes to A, 2 goes to B, 3 goes to C. And in the set B, the element D is remained unrelated. Now, the elements in the set A, all the elements of A have distinct images in set B. Therefore, this function is 1, 1. What I say? All the elements of this set have images in the distinct images in the second set. Therefore, this function is 1, 1. But since the element D is remain unrelated, therefore the element D does not have any pre-images in the set A. Therefore, this function could not be onto. Hence, this function f is 1, 1 but not onto. So friends, I think you have understood the questions 1 and 2. Now proceed to the question 3, which is a set A is 1, 2, 3 and 4 and set B contains the elements A, B and C. And the function f is defined as 1a, 2a, 3b, 4c. The function is in a way that 1a, 2a, 3b and 4c. Now let's see the figure. Here 1 goes to A according to this definition, 2 goes to A, 3 goes to B, 4 goes to C. Now in the figure we can see the elements in the set A, those are 1 and 2 have the same image in the set B. But according to definition of 1, 1, every element of the first set should have distinct images in the second set. But here 1 and 2 have the same image which is A in set B. Therefore, this function f cannot be 1, 1. In the case of onto, since the elements A, B and C in the set B have images in the first set, that is A, therefore the function f is obviously onto. Therefore, this function is not 1, 1 but onto. Right? Now question number 4. The set A contains 1, 2, 3 and B contains A, B, C. And the function f is defined in a way that 1a, 2b, 3b. Now, with the help of this figure, 1 relates to A, 2 relates to B, 2 relates to B, 3 is also related to B, 2 goes to B and 3 goes to B, and the elements is remain unrelated. Now, since the elements 2 and 3 in the set A have same image in the set B, therefore this function cannot be 1, 1. And in the other case, the element C have no pre-images in the set A because C is unrelated. Therefore, this function is f is neither 1 1 nor on 2. Therefore, this function is neither 1 1 nor on 2. Now, come to the question number 2. Which of the following functions are injective and surjective? We are given some functions. We need to check either these functions are injective and surjective. So the first question is f from n to n. F is a function goes from set of natural numbers to set of natural numbers, and it is defined as f of x equal to x square for an element x in the set of natural number. Whenever we are given some type of functions, and if we are asked to check whether this type of functions are injective and surjective, then we may proceed this way. We have to take two elements in the domain. Then so I am ending this video here. I hope you are all enjoying my class. So see you again in the next class. Till then, bye bye, take care.